Achievements of India in space technology and its applications. A latest review. India has been making a big strides in space technology since the last decade. It is now considered as one among the countries leading in space and technology and the space missions, namely USA, France, Germany, Russia and China. And in this essay, I will summarize the many facets of Indian space technology advancements, the role of ISRO in particular, that is Indian Space and Research Organization, and we'll also come to know the latest developments in the Indian space technology and various missions. We'll start with the Mars Orbiter mission. India's Mars Orbiter spacecraft has successfully completed its mission objective as planned, and it has completed 1 year now. It was successfully placed into an elliptical orbit around the planet Mars on September 24, 2014. The Mars Orbiter successfully came out of the solar conjunction in July 2015 using the onboard autonomy built in the spacecraft. The spacecraft is in a good health, and all these 5 scientific payloads are working properly, and they are providing valuable data about the Mars surface features and the Martian atmosphere. The images of Mars captured by the Mars Color Camera have been found to be of very good quality. The increased duration of the observation of Mars by 5 scientific payloads beyond the designed. By successfully placing the Mars Orbiter spacecraft around Mars, ISRO has become the 4th space agency to successfully send a spacecraft to Mars orbit, and India has become the first country in the world to do so in its first attempt itself. Now, how has the mission benefited the country? Number 1, it has upgraded the technological capabilities of the spacecraft design, including onboard autonomy, miniaturization, optimization of onboard resources of the space technology. Secondly, it has provided an excellent opportunities in the planetary research for the scientific community. And third, it has generated interest in youth of the country towards the science and technology. Now next comes the successful launch of the GSLV with indigenous cryogenic stage. Now it is a geosynchronized satellite launch vehicle that was equipped with the indigenous cryogenic upper stage, that is CUS machine, and it was successfully launched by GSAT-6 rocket, and it is the country's advanced communication satellite into a geosynchronized transfer orbit. This was the second consecutive successful flight of the GSLV with the indigenous systems, and it underscored the success of ISRO in mastering the highly complex cryogenic rocket propulsion technology. And it has been considered as a major step in achieving the self-reliance in launching 2-ton class communication satellites into the GTO. Now, third achievement is the development of next generation geosynchronized satellite launch vehicle MK3. The first experimental flight of heavy lift next generation launch vehicle, that is GSLV MK3, was successfully conducted in December 2015 from Sriharikota. This flight has validated the complex atmospheric regime of flight and demonstrated integrity of a design of GSLV MK3 rocket. During the experimental flight, the GSLV Mk3, the unmanned crew module atmospheric re-entry experiment has been successfully tested for its re-entry performance. GSLV Mark III is designed to launch 3.5 to 4 ton class communication satellites to geosynchronous transfer orbits. Next comes the navigational satellite system. The Indian Regional Navigational Satellite System is designed as a constellation of 7 satellites to provide a satellite-based navigational services in the country. This Indian Regional Navigational Satellite System is the 3rd navigational satellite of India, and it was successfully launched on board the Polar Satellite Launch Vehicle of PSLV C-26 on October 16, 2014. This satellite was the 4th satellite in this series, and it was successfully launched on board PSLV C-27 on March 28, 2015. The first 2 satellites were launched on board PSLV earlier in July 2013 and in April 2014. Now, with the operationalization of the 4 navigation satellites in the orbit as mentioned above, it is now possible to provide a position, navigation and time services. This IRNSS constellation of 7 satellites is expected to be completed by 2016. Now, let us see how this navigation satellite system development will benefit India. The IRNSS system, as described above, will benefit the country by providing a positioning services over Indian land mass and a region extending to about 1500 kilometers around India. The convergence of communication, Earth observation and navigation satellite technologies will prove to be a boon in coming years for location-based services and also for arriving at informed decision making. Now there is Gagan, that is GPS aided geo augmented navigation. Now it is primarily being used in aviation sector for precise position information services. With this, India becomes the 3rd country in the world after USA and the European Union to offer a global navigational satellite systems, that is GNSS, and is based precision approach services to civil aviation sector. The Gagan system has been jointly developed by ISRO, and it is a giant leap forward in the development of GNSS services in India, and it will redefine navigation in both aviation and non-aviation application areas. Now, the 5th important development is augmenting the satellite communications infrastructure. GSAT-15 is a 3-ton class communication satellite. It carries 24 Ku band transponders and Gagan payload, and it has been successfully launched on November 11, 2015. GSAT-15 will further augment INSAT and GSAT systems capacity for DTH and TV broadcasting, and also digital satellite news gathering and VSAT services and other societal benefits. GSAT-6 is the country's advanced communication satellite. It carries a S-band payload with 5 spot beams and C-band payload with 1 beam. It was successfully launched into geosynchronized transfer orbit S-band. The satellite has now been positioned in the designed orbital slot of 83 degrees east longitude. GSAT-6 is intended to be used for satellite-based mobile communications with handheld terminal for strategic applications. Now, India also has developed the multi-wavelength observatory in the space. This is another important achievement of the Indian space technology. AstroSat satellite is India's first dedicated astronomy satellite, and it was successfully launched by PSLV C-30. AstroSat enables simultaneous ultraviolet to X-ray observations to study stars and galaxies, and it will also provide opportunity to task observations for the scientific community. AstroSat is also a unique mission with a combination of scientific instruments covering near ultraviolet, far ultraviolet and X-ray bands for the multi-wavelength observations. The ultraviolet imaging telescope of the AstroSat has a best resolution of 1.8 and it combines with a large field view. AstroSat is a vital contribution of India to the global research community in the area of the astronomy. The next comes the commercial launch of PSLV. India's Polar Satellite Launch Vehicle has launched 17 foreign satellites from 7 countries, that is Canada, Indonesia, Singapore, UK and USA during 2015. One of the most important contributions and the development in the space technology of India is its application in the matter of disaster management support. The Indian remote sensing, the meteorological and communication satellites have immensely helped in the management of recent events of disasters witnessed by the country. For example, the Jammu and Kashmir floods, Hudhud cyclone, and the Jammu and Kashmir landslides that have taken place recently. These satellites have provided a near real-time support in terms of early warning, assessment of damages, emergency of communication. The massive landslides blocking San Koshi River in the northern Nepal in August 2014 and Futkal River in Janskar region in Jammu and Kashmir in January-March 2015 were in fact monitored regularly using our Indian remote sensing satellites. Now, flood inundation maps and information on their progression and recessions were also disseminated on daily basis to the concerned agency through the help of our satellites. During the recent earthquakes in Nepal, remote sensing data obtained from the Indian and foreign satellites was analyzed in a near real time to identify the collapsed structures and new landslides resulted due to earthquakes in the parts of Nepal. Further, the processed information derived from the satellite data was provided to the national agencies. For example, the Ministry of Home Affairs, the National Disaster Management Authority, the National Disaster Response Force, and also international agencies like British Army, the International Center for Integrated Mountain Development, Nepal, National Intelligence Agency of US, and UNOSAT, and other relief teams of Nepal, Korea, Russia, France, Germany, etc. And it helped unifying the efforts and coordination of rescue operations. Now, let us see the innovative programs of the Indian space technology missions by using a space application and the expected positive impact on the general public. Number one was the identifying the water bodies in the tribal dominated districts which could be developed to culture fisheries. The tribal inhabitants require regular income mechanisms instead of the current assistance protocols which deliver resources only in a periodical fashion. The Ministry of Tribal Affairs therefore has a program on identifying existing and potential water collection spots, and this could be developed for fish culture. Now, ISRO also has provided maps for small water bodies generated using satellite data. In order to use these satellite-based maps, capacity building for the state-level officers has been done in Odisha, West Bengal, Northeast, Gujarat and Jharkhand. This enables identifying existing water bodies and identifying new sites wherein runoff can be harvested for fish cultivation along with the conventional agricultural farming. Now, water body database therefore will be used to plan enhancement of fishery as a livelihood alternative or livelihood augmentation in the tribal areas. Small water body based fishery therefore can help tribal inhabitants to get a regular nutrition as well as income. The second most important impact on the general public has been the monitoring and evaluation of developmental activities in the watershed areas. Now, the Department of Land Resources program on integrated watershed management is for restoring ecological balance by harnessing, conserving and developing degraded natural resources such as soil, vegetative cover and water. ISRO is providing online satellite data, tools and mobile applications through Bhuvan Geo portal, that is for monitoring of watershed and developmental activities. The effective implementation of this project will ensure optimal soil and water conservation and assured crop irrigation due to water resources harvesting, and this will help provide sustainable livelihoods to the people that are residing in the watershed area. Further, farmers will get their livelihood on sustainable basis due to the biomass improvement also. The desilting of tanks and other watershed activities that provide employment generation under MG Narega are also being evaluated using the satellite data provided by ISRO. Now, third important aspect is the space-based information support for decentralized planning activity. Now, using a high-resolution satellite data, state-wise natural resource database is being generated for the entire country at 1:10,000 scales. And this spatial database integrated with the field level information and traditional wisdom will help in the preparation of local specific action plans for land and water management and also for the development of their locality. Now, the Bhuvan Panchayat portal provides functionaries required to carry out the decentralized planning process at a grassroots level. Citizen in general and 3 tiers of Panchayat Raj institutions, that is Gram Panchayat, Block Panchayat and District Panchayat in particular, are the users of this Bhuvan portal. This portal helps the PRIs, that is Panchayat Raj institutions, in tracking the progress of work undertaken by the citizens under various schemes. Our space technology also helps the conservation of heritage sites. The conservation of World Heritage Sites, ancient monuments and archaeological sites is of a national importance because it helps in development and promotion of tourism, and tourism, as is well known, is a major engine of economic growth. The systematic database of heritage sites and the site management plans generated using a space technology, and this will help to take informed decisions in the conservation, preservation and monitoring activities of the site. The space-based technology tools are also being planned for mapping and identification of vulnerability of each monument, and also for the preparation of plans to track and also mitigate environmental or weather changes that may have an adverse effect on the fragile monuments. One of the most important impact in the day-to-day life has been the automated warning at unmanned level crossings. Pilot studies for automatic warnings at unmanned level crossings have been carried out using a Gagan rail navigation tools. It is a MSS based tracking system and Bhuvan portal. It comprises of geospatial database on the accurate locations, that is geographical coordinates, of unmanned level crossing and Gagan enabled devices mounted on the train engines. A train mounted with such device would know the location of unmanned level crossings, and train's hooter will automatically start when it approaches near the place of unmanned crossing, and expert committee and councils are being set up by the railways to discuss and finalize the modalities of actual implementation. The space technology has a great role to play in weather and climate aspects of the country. Indian meteorological satellites provide a synoptic measurement and derivation of various weather parameters such as cloud motion vectors, cloud top temperature, water vapor, humidity, rainfall at frequent intervals, and this aids in improved weather forecasting, including genesis of cyclones, their track and landfall prediction. The data products are disseminated through web-based services for the needs of the scientific community in the country at large. Now then comes the data connectivity to rural India. Department of Science and ISRO have fast-tracked the realization and launch of GSAT-11 communication satellites. GSAT-11 is an advanced communication satellite with the Ku and Ka band communication payload, and they are capable of providing up to 10 Gbps throughput. With such a capability, this satellite is expected to provide a high bandwidth data connectivity for rural India. And this is a part of the Digital India mission. Satellite structure is already realized and the payload fabrication is in progress. The initiatives have been taken to accelerate the development and realization of other critical subsystems of the satellite. The satellite is targeted for a launch in the year 2017.